Hello everyone, I'm back with another video, and today we are going to talk about alkenes. In the first lesson of organic chemistry we talked about alkanes, and now we are going to talk about alkenes. Its general formula is CnH2n and its suffix is -ene, which means that all the alkenes have -ene at the end. Okay, and its functional group is the presence of at least one carbon-carbon double bond. At least one carbon-carbon double bond. Okay, now let's start. If n is equal to 1, so I'm going to follow the same template. First one will be the molecular formula, and then we'll write the structural formula, and then we'll write the name. Okay, so molecular formula would be n is equal to 1, which means C1H2. So CH2. But the problem with this is we know that alkenes must have a carbon-carbon double bond, and hydrogen cannot form a double bond with anything, let alone carbon. So carbon at least needs another carbon to form a double bond. Okay, so methane does not exist. If it had existed, its name would have been methane, but it does not exist. So one carbon atom alkene does not exist. Remember that there is no one carbon atom alkene. Okay, it does not exist. Okay, for n is equal to 2, the molecular formula would be C2H4. Okay, and that will be, and its structural formula would be C double bond C. So you'll have to complete 4 bonds of carbon. So 2, 1, 2, 3, and 4. 1, 2, 3, and 4. Okay, and its name would be ethene. Its name would be ethene. Okay, so 2 carbon atoms start with eth or eth, and it will end with ene, ethene. For n is equal to 3, C3H6 would be the molecular formula. You plug in C3H6. So hydrogen atoms are actually twice the number of carbon atoms, unlike alkanes in which hydrogen atoms were twice the number of carbon atoms plus 2. Okay, so C3H6, C double bond C, C, H, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, and 4. That would be propane. Okay, just in O level, just introduce double bond on the first carbon atom. Okay, just start with carbon-carbon double bond. You are just required to understand or observe or evaluate alkenes which have one carbon-carbon double bond. Okay, then n is equal to 4. That would be C4H8. Its structural formula would be C double bond C, C, C. 1, 2, 3, and 4. 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 Its name would be butane. Butane. Okay, so ethene, propane, and butane. And for n is equal to 5, the name would be pentene. For n is equal to 6, the name would be hexene, then heptene, then octene, nonene, and decene. It goes on. You can make all those structures for practice, but I'm going to move on to its properties. So how are they prepared? How are alkenes prepared? So let's talk about the preparation. The preparation is done by a process called cracking. Okay, it's a process called cracking. Cracking is what? Cracking is conversion of large chain hydrocarbons. Conversion of large chain hydrocarbons into small chain, large chain hydrocarbons which are less desirable. Large chain hydrocarbons are usually less desirable. Okay, so conversion of large chain hydrocarbons to small chain hydrocarbons which are more desirable. Small chain hydrocarbons which are more desirable. And how do we do that? We do that by the action of heat or catalyst. There can be thermal cracking or there can be catalytic cracking. By the action of heat or catalyst, CLI. Let me just correct the spelling over here. Catalysts. Okay, how does it work out? Now let's say you have a big alkane. Generally the type of cracking equation that you will encounter is you have a long chain alkane. You'll have a long chain alkane which will split into small chain alkane and small chain alkene. Okay, and in some cases hydrogen is released as well. Okay, so yes, so let's say we have C18H38. It's a big alkane of 18 carbon atoms, and he asks you that there is a big hydrocarbon C18H38 and it cracks to form C9H20, and he asks you what would be the other compound. So you would see that this is an alkane, since the carbon atoms, the hydrogen atoms are twice the carbon atoms plus 2. So you will make an alkene accordingly. How? So how many carbon atoms are used? 9. So you will have to make a 9 carbon atom alkene as well. Now C9 and H would be 18. If you add the number of carbon atoms and the hydrogen atoms, you will get this alkane. C9, C18, H20, H18 would be H38. Okay. But if they don't tell you one of the products, you can actually pick and choose. You can make a 4 carbon atom alkane and then a 14 carbon atom alkene, and so on. Even you can split this into bigger molecules. You can split it into hydrogen and an alkene. You can even do that. Okay, just remember that alkenes are prepared by cracking. And the industrial preparation of hydrogen is also from cracking, like we studied in Haber's process, that hydrogen comes from cracking of oil. Oil means long chain alkanes, okay, or long chain hydrocarbons in general. So let's talk about their reactions. Okay, the first reaction that they give is actually contains itself a lot of reactions. There are addition reactions. Okay, to understand addition reactions, you need to understand their property that they are unsaturated hydrocarbons. Alkenes are unsaturated hydrocarbons. Why do I say that? Alkenes are unsaturated hydrocarbons. Unsaturated means that they still have the capacity. They still have the capacity to add things in them. Okay, for example, in alkenes there is a carbon-carbon double bond. Okay, and if this bond is broken, let's say there is a compound XY reacting with this particular compound. Now, if this bond is broken, this double bond is broken, one bond of carbon on the right and one bond of the carbon on the left will get free. Now, each X and Y can easily join. You can easily be added to an alkene. So that's why these alkenes undergo addition reactions and not substitution reactions. Substitution reactions only happen in alkanes because they are saturated. They do not have any capacity to accommodate any incoming electrons. They can only be substituted. But alkenes have the capacity to accommodate incoming atoms, so that's why they undergo addition reactions. Okay, the first thing we'll study is addition of hydrogen. Let's talk about addition of hydrogen. Right. So let's take ethene, C2H4 reacts with hydrogen, and what will happen? It will just be added. C2H6 will be formed. Only one product is formed in addition reactions. Things are just adding together into one single product. Okay, and you need to remember its conditions. Nickel is used as a catalyst, and temperature is around 180 degrees Celsius, and this reaction is used to make margarine. That's what we studied in the transition elements as well, that nickel is used to make margarine. Okay, margarine is what? Margarine is basically solid fat. that you also know it. Blue Band is actually margarine that you use in breakfast. Blue Band is pretty famous to be used in breakfast. Even initially, Blue Band was initially marketed as butter, and then they got sued for that because it was not butter; it is margarine. Okay, it is different from butter, and obviously, it will not have the nutritional value of butter. Okay, how is it making margarine? Remember that the oils that we have at home, which are liquid at room temperature, they have double bonds. They have double bonds. Okay, and the ghee that is not liquid at room temperature. Ghee is not liquid at room temperature. Why is that? It has less double bonds as compared to liquid oil. So whenever you have to solidify fat, you'll have to break its bonds, and one way of breaking its bond is to add hydrogen into it. Okay, so let's say if I have a huge chain of an oil, let's say I have a big chain of oil, there are double bonds everywhere. Okay, I keep on adding hydrogen, these bonds keep on breaking down. Let's say I broke all these bonds. Basically, liquid oil will convert into solid fat. This process is called, we are basically saturating vegetable oil by adding hydrogen. Okay, that's how margarine is made. Okay, vegetable oil is saturated to make margarine. Okay, now this was the first addition reaction. Let's move on to another one. Another one is addition of bromine. It's a very important reaction. Why is that? Because it is used as a test to identify alkenes from alkanes. How? Let's discuss that. Ethene reacts with bromine to form bromoethane, because it will simply be added C2H4Br2. Okay, bromine has an orange red color. Okay, and when this reaction happens, the solution becomes colorless. Okay, so bromine can actually be used to distinguish or to differentiate between alkanes and alkenes. Let's say I have a solution and I don't know whether it's an alkane or an alkene. What would I do? I would add aqueous bromine into it. This is aqueous bromine. So what was I saying? I was saying that, for example, if I have a beaker of a solution and I don't know whether it's an alkane or an alkene, I will add aqueous bromine. If it changes color from orange red to colorless, then we know that's going to be an alkene, and if it doesn't change color, it is going to be an alkane, because bromine does not react with an alkane, does not give an addition reaction with alkane. So the test for alkenes is basically that you use aqueous bromine, and the observation is that orange red bromine decolorizes. If you do the past papers, the topical questions, you will see this question so many times that you will get sick of it. Okay, so they can ask you, they're not going to ask you directly that which test is used to distinguish between alkanes and alkenes. They can also ask you which test is used to distinguish between unsaturated and saturated hydrocarbons. So you should know that unsaturated hydrocarbons are alkenes and saturated hydrocarbons are alkanes. Okay, now the third one is the third addition we have is addition of steam. Whenever you add steam in, let's say, alkenes, I'm adding an ethene, okay, in the presence of phosphoric acid as a catalyst, and at 300 degrees Celsius alcohol is formed. This is called ethanol. Alcohols have ol at the end. You're going to study this reaction in alcohols as well. This is the chemical property of alkene and the preparation of ethanol. So you're going to study the same reaction in alcohols as well as their preparation. Okay, remember these conditions, they are very important. Okay, so these are all the addition reactions. Now let's move on to combustion reactions. They actually follow the same vein that we studied in alkenes. Okay, all the organic compounds are going to have a complete combustion in oxygen to form carbon dioxide and water. So let's do that. I'm taking ethene. Let's say I'm taking propane this time. C3H6. It will react with oxygen to form carbon dioxide and water. It's the easiest reaction to write. Carbon 3, carbon 3, hydrogen 6, hydrogen 6. 3 2s are 6 plus 3, 9 oxygens, so 9 over 2 oxygens. You don't like to write in fractions, to multiply this whole equation by 2. This is removed, so you have 6 and you have 6. You can also write it like this. It's your call. Okay, this was combustion. The last type of reactions that they give are called polymerization reactions. Polymerization reactions. We are going to study these reactions in macromolecules as well, but I'm just going to give you a small intro to it. Okay, so what is polymerization? Polymerization is when small molecules join together to form a giant molecule. Small molecules join together to form a giant molecule. Okay, these small molecules are called monomers, and this giant molecule is called polymer. So we can say that monomers join together to form polymers. Okay, this reaction only happens in alkene because it has the capacity. Because you need what? Small units. Let's say I'm talking about ethene here. Okay, and ethene is joining together to form a polymer, that is polyethylene. Now, why can ethene undergo polymerization and not ethane? Because ethene has a double bond. So when it breaks, its right hand side and left hand side, okay, carbon on the right and carbon on the left, both will have a bond to make. Okay, so they are going to shake hands with the adjacent alkene molecule. Okay, which will also shake hands with the adjacent alkene molecule. So that's why in alkenes polymerization happens. Okay, what happens is that the bond is broken. Now both the carbons that were initially forming double bond are now free to make bonds with the adjacent molecules. Let me write it properly. Let's say I'm converting propene into polypropylene. Okay, so what is propene? Propene is CH double bond. In fact, just write it like the C double bond C C H H H and H and H. Okay, this is propene. So n number of propene molecules are going to meet together. Why n? Unlimited number of propene molecules are joined together to form polypropene. But how do they attach? You need to understand that this bond is broken. This bond is broken actually. This bond is broken. So you have to arrange everything accordingly. So when this bond is broken, carbons, this bond will open automatically. When this opens, the whole chain or everything that is attached to this carbon will become its branch. Okay. Now what will happen here? If I just arrange it properly, it would be something like this: C double bond C, CH3, H, H, and H. I can write it like this, just to make room on the right and left of the carbons that are forming double bonds. So n number of these are joining together, so they are going to make polypropene. Okay, they are going to make polypropene. So there will be HCH3. This bond will break and will attach itself to adjacent propene molecule HCH3. Okay, N means that they are being repeated. They are being repeated n times and n time is the actually the number of monomers. So they are going to be repeated by the time of the monomers. मतलब in simple words you can say that ये n जो है ये इतनी दफ़ा ही repeat होगा जितने ज़्यादा monomers होंगे ये उतनी दफ़ा ही repeat होगा. Okay, now right now I have repeated it 2 times. So you can say that this polymer, I have shown this polymer with 2 repeating units. Okay, because I have repeated this unit twice. If they often ask you, but in fact I'm going to just explain it to you later when we do macromolecules. Right now just remember the fact that monomers join together to form a polymer, and only happens in alkenes because they have a double bond, they are unsaturated, and they have space, to make more bonds with adjacent molecules, and this chain just goes on and on and on. Okay, so that is polymerization. Now let's do some past paper questions related to alkenes. So question number 1, how can alkenes be manufactured? Just we did by cracking of hydrocarbons. Okay, when cracked, 1 mole of a compound produces 1 mole of propene and 1 mole of hydrogen. Okay, what type of compound is X? We know that alkanes break down into alkene and hydrogen. If you join together, this alkane would be C3H8. That's why it broke down into C3H6 and H2. It has to be an alkane. Okay, which statement about vegetable oil and margarine made from it is correct? Both are liquids at room temperature? No. Both occur naturally? No. Margarine is manufactured. Margarine has a higher melting point. Vegetable oil has fewer carbon-carbon double bonds than margarine. No, margarine has its opposite. Vegetable oil has more carbon-carbon double bonds than margarine. So margarine will have the higher melting point. Obviously, it's solid at room temperature, so it will have a higher melting point. Okay, moving on. Which partial structure is correct for the polymerization of butene? If you are polymerizing butene, it means that this bond is going to be opened, so all of this on the right will become its branch. All of it will become its branch, something like this: CH2, CH3. Okay. Now, keeping this in mind, now just check which one will be the polymer of butene. This seems like it, right? Hydrogen, CH2, CH3, CH. You can also write it like this: CH, and this H you can write it like this. So this seems like this one. So A would be the answer. So these bonds will be broken, right and left, and polymer will be formed like this. So this is a polymer that is showing only one repeating unit. They often, when they ask you to draw a polymer, they will always tell you to write the polymer in a particular number of repeating units. If they say in one repeating unit, you can simply draw it. You can simply break the bond at the center and extend the bonds on the right and left, and put the bracket and write N at the bottom. Now, compound Q reacts with bromine to form the compound shown. Okay. Now, this is clearly addition reaction. Compound Q reacts with bromine to form the compound, which means because alkenes react with bromine and with bromine Br2, and both the bromine atoms are added, so it has to be an alkene. Okay, so all of these bonds are shown. Okay, it cannot be A, it cannot be B, because it already has Br, and the end product has 2 Brs. If the end product had 3 Brs, then we could have chosen A or B. Okay, because it will be reacting with something, will be reacting with Br2. Both the bromine atoms are going to be added. So A and B cannot be the answer. You are left with C and D. If you see C, this bond is broken. Let's say this bond is broken. Okay, and one bromine is added here and one bromine is added here. And if this bond is broken, one bromine is added here and one bromine is added here. Remember that bromine is added on those carbon atoms. Addition happens on those carbon atoms where double bonds exist. Okay. Now this doesn't look like this. Bromines are present on carbon 1 and 2. They are carbon 1 and 2. So answer would be C. Okay, with which substance will ethene react to form more than one product? Bromine, hydrogen, steam, all of them are addition. All of them have addition reaction with ethene which form only one product. But with oxygen, ethene will produce carbon dioxide and water. So answer would be C. Which compound is manufactured by reacting ethene with steam in the presence of heated catalyst? It would be ethanol. Ethene and steam react to form ethanol. Okay. So a student investigated the reactions of different vegetable oils. 100 centimeter cube of hydrogen was passed through vegetable oils. Volume of hydrogen remaining after each reaction was recorded. P, Q, R and S. 100 centimeter cube of hydrogen was passed. So in P, no hydrogen was absorbed. In Q, some hydrogen was absorbed. In R, some more hydrogen was absorbed. And in S, all of the hydrogen was absorbed, which means all of the hydrogen was added, which means S is going to be most unsaturated. So which vegetable oils are unsaturated? All of those which have actually absorbed or allowed hydrogen to be added, they are going to be unsaturated. Okay, because if hydrogen volume is being reduced, it means that it is used to break the double bonds in Q, R and S. So answer would be C. Which compounds decolorize bromine water? This is ethene, it will decolorize. This is propene. Ek do thing. This is propene, it will decolorize bromine water. So 2 and 4. What is the structure of the product of the reaction between butane and bromine? If you add bromine here, so one Br would attach here, one Br would attach here on the last two carbon atoms. So D would be the answer. Last two carbon atoms are Brs. So next question is, draw the structure of propene. So C double bond C, C, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3 and 4. Write the equation for this reaction. That hydrocarbon is cracked to form propene and one other hydrocarbon. So 15H32 is cracked to form propene, which is C3H6, and one hydrocarbon has to be an alkene because alkene is formed. Now smaller alkane will be formed. So C12H26. Add them together and you'll have this. Okay, moving on. Describe how propene can be converted into an alcohol and draw the structure of this alcohol. Okay, you will be most suited to do this once you have done alcohols. Draw the structure of polypropene showing at least 2 repeat units. So polypropene, let's draw propene first. You are required to draw the structure of polypropene. Okay. So C double bond C, C is propene actually. When this bond breaks, this goes here. Right? You can write it like this. Okay, now these are going to attach together to form polypropene. I have not added hydrogen here. I'm going to add hydrogen now. So C, H, C. In fact, there is no H over here. Let me remove it again. Let me redraw it. Okay. So I'm starting from this is attaching with another of the same structure. Since they're asking you to show 2 repeating units, you'll join them together. How would you join them together? C, 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 C. Okay, these double bonds are broken. On the right hand side, they helped, and on the right hand side, this carbon used that bond to bond with the next carbon atom, and the left and the right one you'll have to show like this. Okay, you will have to show the hydrogens, hydrogen, 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 n number of things. Okay, this will be the structure of polypropene with 2 repeating units. Define the variation in which physical property is used to separate crude oil by fractional distillation, that is boiling point. Boiling point is used to separate, is the property that is used to separate crude oil by fractional distillation. Define the term cracking. Cracking is conversion of large chain hydrocarbons into small chain hydrocarbons by the action of heat or catalyst. Use information from the table to explain how cracking helps an oil refinery match the supply of gasoline with demand of gasoline. If you see the supply of gasoline, the percentage in crude oil is 11%, but demand is 22%. On the other hand, if you see the compounds with greater carbon atoms, which are not that useful, their percentage is 18 and 23%, but their demand is only 15 and 4%, much lower than their availability. So what do? We crack these. We crack these heavier hydrocarbons and we crack these to form more compounds like gasoline. So that's how cracking helps an oil refinery match the supply of gasoline with demand of gasoline. So we'll crack heavier hydrocarbons like gas oil and bitumen to be converted into more desirable hydrocarbons like gasoline, to make sure that the supply of gasoline meets the demand of gasoline. That's what you write over here. Explain the meaning of the term polyunsaturated. Polyunsaturated means more than one carbon-carbon double bonds. More than one carbon-carbon double bonds. Describe how you could distinguish between saturated and unsaturated vegetable oils. You can use aqueous bromine. Okay, you can say the orange-red bromine decolorizes. Orange-red bromine. You will add aqueous bromine. Orange-red bromine will decolorize in unsaturated vegetable oils. In unsaturated vegetable oils. Okay. Describe how margarine can be manufactured from unsaturated vegetable oils. So you'll add by adding hydrogen in the presence of nickel catalyst and at 180 degrees Celsius. You need to remember these conditions. Unsaturated means compound which contain carbon-carbon double bond. And what would you observe when excess isoprene is added to aqueous bromine? Orange-red bromine will decolorize because isoprene has double bonds. It's unsaturated. Okay, you can do that. Use the structure to explain why propene is both a hydrocarbon and unsaturated. You will draw the structure of propene. One hydrogens, one, and we'll explain why propene is both a hydrocarbon and unsaturated. Propene has only hydrogen and carbon, that's why it's a hydrocarbon, and it is unsaturated because it has carbon-carbon double bonds. Okay. What is the physical state for butene at room temperature and pressure? Explain your answer. So you'll have to go back to the table. Why butene is a gas at room temperature? Because its boiling point is less than the room temperature. That's why it is a gas at room temperature and pressure. Okay, that's all. Give the molecular formula of the product with bromine. Butene reacts with bromine and with steam. So what will the molecular formula of butene reacting with bromine? Butene is C4H8. When it reacts with bromine, the compound that will be formed will be C4H8Br2. And what would be the name of the product with steam? Okay, they are asking the name of the product with steam. So when butane reacts with steam, we studied when ethane reacts with steam, ethanol was formed. So when butane reacts with steam, butanol is formed. You will grasp it better once we do alcohols. So that's all from alkenes. I hope you got all the concepts right, like I often say. Inshallah, I'll be back with another video on alcohols. Until then, stay tuned and keep watching O Levels Pro. Allah Hafiz.